Hi friends, good evening. Welcome to my channel, Belagali's classes, Belagali's class. Yes friends, we have completed with what? The entire differentiation, including continuity of a function as well as mean value theorems, even that also we have completed. That part of one unit, what is that? Derivatives of a function or continuity and derivatives of a function. That part we have completed. Everything, my friends, we have done very systematically, considering more number of examples from your textbook. Even I referred with your question papers, model question papers. Everything refer, prepared the things, notes, then yes, my friends, talk to you. Yes, this part is completed. A very important part of this calculus. Equally important part of calculus is integration. Yes, my friends, we have completed differentiation. We are inviting, welcoming integration. Now, the welcome or introduction of this integration is good if the differentiation, this preparation of this differentiation is good. If the differentiation, if the concepts, everything are done under differentiation, if the things are clear, then automatically you can understand what this integration very, very better, very nicely you can understand it, my friends. So both are what made each other. Differentiation, next integration. Integration mainly depends upon your differentiation. That is why, my friends, while introducing this integration, the first line itself, see, integration is the reverse process of differentiation. Integration is the reverse process of differentiation, my friends. Integration is the reverse process of differentiation. Differentiation. Yes, my friends, you can reverse the process. If you know perfectly this. Why? You are reversing this differentiation, we can get what? Integration. If this person is weak, reversing becomes weak. Why? Newton's law, action, reaction. If the action is good, reaction is good. If the action is poor, reaction is also poor. By Newton's law, my friends. Therefore, you must be very well prepared of the things done in case of what? A differentiation. Then only you can reverse the process very nicely. We can do what? Better in integration. Yes, therefore, integration is the reverse process of differentiation. Agree. What is differentiation? In differentiation, this differentiation is the method of finding the derivative. Differentiation is the method of finding the derivative of a function. Yes, my friend. If y equal to fx is a function, what is the differentiation? It is a method of finding its derivative dy by dx. Yes, my friends. We have done derivatives of algebraic functions, exponential functions, logarithmic functions, trigonometric functions, inverse trigonometric functions. Not only this, we have done what? Derivative of u plus v, u minus v, product formula, derivative of u v, derivative of u by v. Then not only this, we have done what? Derivatives of implicit functions, parametric functions, logarithmic differentiation, and trigonometric, inverse trigonometric functions. So many varieties of examples, my friends, we have done under differentiation. Yes, my friends. This integration will be very good if this is good. Differentiation. Yes, my friends. See. is that? If y equal to fx is a function of x, then method of finding the derivative of y, that method is known as differentiation. Yes, my friends. Now you reverse the process. You have come from y to dy by dx. You have come from y to dy by dx. Reversing at this moment, this stage, you have to reverse it. Reverse means you have to go back. What is the original here? Dy by dx. With the help of the derivative of a function, you have to find what? The original function. The method of finding the original function with the help of its derivative, that method is known as integration. That method is known as integration. See, my friends, we have completed above from y to dy by dx. Again, you have to go back from dy by dx to original function. Therefore, if you apply both the differentiation integration, on any function, finally we arrive where? At the original function itself. If we apply both the methods. Yes, my friends. The same thing is written. Reversing. Integration is the method of finding the original function with the help of its derivative. Yes, my friends. So remember, if you apply both on a function, we get original function. Yes, we will see now. We define the integral. We define integral of a function as follows. My friends have written there. This is the definition. Yes, my friends. If fx and gx are two functions of x, such that derivative of one function is another function, derivative of gx is fx. Yes, my friends. This fx and gx are connected by this. What is the connection? Derivative of gx is fx. For example, I write, my friend, here. This is derivative of sin x. Derivative of sin x with respect to x is cos x. Yes, friend. Here. What is this fx? This fx is the derivative of gx with respect to x. Here, fx is the derivative of gx with respect to x by this symbol. Reverse it. You have to come back from this to this. You are going. What is fx? Derivative of gx. See here. Fx is the derivative of cx. See here. What is cos x? Derivative of sin x with respect to x. Now you reverse it. Reversing this gx. Fx is the derivative of gx. Gx is, by the definition, what is the definition? Reverse process is integration. You are doing the reversing. Gx is the integral of fx with respect to x, and is written symbolically as, yes, my friends, this is your yes. This yes, we write it little what? Stylish, fancy. Even somebody will pronounce it as what? Big S, small s, big S. This is a symbol to denote what? Integral. It is an integral sign. Integral of fx with respect to x. Therefore, my friends, thus, if d by dx of gx is fx, then integral of this RHS means what? Fx, symbolic way written here. Integral of RHS with respect to x is this bracket. What is that bracket? Gx. Same thing here, my friends. D by dx of sin x is cos x. Reversing. Integral of cos x, integral sin integral of cos x with respect to x is sin x. Integral of cos x with respect to x is sin x. This is the process. Nothing. See how the mathematicians use their brain. They have used in brain finding what? Derivative. The method of finding the derivative is known as differentiation. This is finished. Again they have started what? Another mind, fresh mind. Yes, my friends, we have come from here to here. Is it possible to go back? Yes, it is possible. With the help of the derivative of a function, the method of finding the original function, that method is known as integration. This itself, my friends, we know that derivative of sin x is cos x. Yes, what is cos x? Derivative of sin x. Reverse it. Reversing what you get? New name. This is one name, differentiation. What is another name? Integration. All these names are by whom? Mathematicians. Yes, my friends. Reversing, that reverse process is known as integration. Therefore, symbolic way, big yes. Somebody is saying otherwise, you say whatever it is. Stylish way of writing the yes. Yes, my friend. Integral of cos x with respect to x is sin x. Derivative of sin x is cos x, and integral of cos x is this bracket, which is sin x. This is, my friends, what? Integration. Integration. Yes. My friends, 1 minute if you wanted to see. Say it. Say it. Yes, friends, even to the board exam, the contribution of this integration among 100 marks is very good enough. How many? Totally 22 marks, my friends, related with your board exam. See, 1 mark, 1 question, 2 mark, 2 examples or 2 questions, 3 mark, 2 questions, 5 mark, 1 question, 6 marks, 1 question, 6 plus 5, 11 plus 6, 17 plus 4, 17 plus 4 is 21, 21 plus 1 is 22. It is good enough, my friends. Even if you go with the CET, there also you get what? Around 5 to 6 examples in integration. Very good. Not only for your board exam or your CET. If you join with what? Any branch connected with mathematics, mainly engineering, without integration, there is no engineering, my friends. If anybody wanted to join, have a plan of joining engineering, if anybody wanted to do better, good in engineering, the friend must be good, better, best, where? In integration. So much, my friends, important this chapter. Saying the introductory part of what? This integration. Main points, highlights. Only I will just repeat it. Integration is a reverse process of differentiation, one line. Differentiation is the method of finding the derivative of y with respect to x from y to dy by dx. What is integration? It is a method of finding y with the help of dy by dx. Yes, integral of fx with respect to x. That integral of fx with respect to x. Integral of fx with respect to x. We denote integral of fx with respect to x. Denoted, written symbolically as what? My friend, yes. Integral fx dx. Yes, this is definition. Yes, my friends. Remember. Here, the mathematicians have taken the use, or you can say advantage, or anything of what? Derivative of a constant, my friends. Tell. What is the derivative of constant? The derivative of constant is 0. Derivative of constant is 0. Yes, we know that derivative of any constant c, otherwise, right, okay, you know it, derivative of any constant is 0. Making use of this, I write another result, my friends. That result I give it as what? Note. If d by dx of gx is fx and c is any arbitrary constant, then my friend, d by dx of gx plus c equal to, my friend, it is d by dx of first function is gx plus second function, what is it? Derivative of constant with respect to x. What is the derivative of gx? We have taken this as fx plus what is this, my friend? 0. Fx plus 0 is what? Fx. Yes, my friends. Therefore, d by dx of gx plus c is fx. Then tell my friend, use definition. Integral of RHS, then it is what? Integral of RHS fx with respect to x is dx. Is this bracket, my friend? What is this bracket? gx plus c is gx plus c. Hope understood what I have written here. Remember, if the derivative of gx is fx and c is any arbitrary constant, what do you mean by this? Is constant? Yes, constant means, sir, we know it. Then what is the meaning of arbitrary constant? Yes, it is a constant c. This c can take any fixed values. C may be 2, why 2 is a constant. C may be 4 is also constant. C may be 5, it is also constant. C may be 10, it is also constant. Then this c being arbitrary can take any fixed constants. We can write c equal to 2, it is a constant. Why? Derivative of 2 is 0, like this. You can take 4, why? Derivative of 4 is 0, derivative of 5 is 0, derivative of 10 is 0. Here, my friends, you can take c equal to 2, c equal to 4, c equal to 5, c equal to minus 10. So many fixed constants is correct. In that case, this c can take any fixed values. In that case, that c is said to be arbitrary constant, means according to your choice. Belagali wanted 2, yes, right. Another friend wanted what? 4, yes. Another miss wanted what? 5. All these man with liking, so arbitrary according to our choice. Yes, my friend. Then the derivative of this expression is what? Derivative of first plus derivative of second. Derivative of first we have taken fx. Derivative of c is 0. So derivative of this is fx. Reverse it. You are reversing. If d by dx of gx equal to fx, then reversing. Integral of RHS is this bracket. Integral of RHS. What is RHS, my friend? Fx is this bracket. What is bracket? Gx plus c. Therefore, my friends, in this C plays a very important role. This C plays a very important role. Now, what is that important role? Due to the different values of C, this RHS is not definite, my friends. The values of RHS will change. If C is 2, one value. If C is 4, another value. If C is 5, another value. Like this, and the value in RHS is not fixed. Therefore, the integral in RHS is not fixed. It is not definite. Therefore, integral in RHS, that is fx dx, because of this C, this integral is known as indefinite integral. Indefinite. And they are known as indefinite integral or integrals. Yes, my friends, indefinite integrals. Because of C, my friends. Now you have the name. This is integral sign. Next, it is a function to be integrated. Fx is a function to be integrated. It is called as integrand. This dx denotes, my friend, integration is to be performed. Integration is performed with respect to x. This is dx. And what about this C, my friend? This C is called as constant of integration. Constant of integration. Constant of integration. Yes, my friends. I hope understood. This I explained. In this sign, it is an integral sign. It is a function to be integrated. Function to be integrated is known as integrand. Dx, integration is performed with respect to x. This denotes performed with respect to x. This, my friend, C, the constant of integration. Yes, my friends, this is about indefinite integral. Why it is indefinite? Because of indefinite value of C. C is not definite. C changes. As C changes, the value changes. It is not definite. So that such integrals are known as indefinite integrals or indefinite. Only one is there, integral. This is what, my friend, about the definition of integration. Definition of integral. Then the method of finding the integral of a function. The method of finding the integral of a function. Integral of a function with respect to x is called as integration. Is known as integration. Yes, my friends, this is integration. Yes, in this, what we have to do? We have to find the integral of a function. To find the integral of a function, use what? Derivative of a function. See the connection. To find the integral, use the derivative. Where is the derivative? In your pocket already we have done months together the method of finding the derivatives of a function. Just we have to remind everything. Then we have to list a formula in integration. Then as usual, integral of sum of two functions, difference of two functions, product of two functions. Quotient is not there, quotient rule, product rule is there. Like this, my friends, it all comes. When it is indefinite, then there comes what? Definite integral also. Definite integral also. Then properties of definite integrals. theorems, examples. As usual, the usual mathematics, my friends, starts. That is called as algebra of derivatives. What is it? Derivatives of sum, difference, product, division. Here, the algebra of this is what? Sum of two functions, integral of two functions, sum of two functions, integral of difference of two functions, integral of product of two functions, like that. This starts, my friends. Remember, this is everything, the brief introduction of what? My friends, integration. 1 minute to look at it. Yes, my friends, you know the importance of this corner. Always, with my teaching, this corner is a source of what? Formula. Source of formula. Yes. What is first definition? Definition. What is that definition? If d by dx of gx equal to fx, then another sign, integral sign. Integral of fx dx is what? Bracket. What is that bracket? Gx. In case of integration, we are adding c. In case of integration, we are adding c. Why we are adding c? Because of derivative of c is 0. Otherwise, if you write here itself, anyway, no need. You have to add what? This c. My friend, this is definition, and this is definition of what? Integral. Next comes properties. First property is integral k of x dx is what? It is k into, what is that k? Constant, my friends. Constant. That k can be taken outside the integral. This is 1, my friend. Another property. This is integral of two functions fx plus gx with respect to x is first integral of first function plus is plus integral of second function. Yes, my friend, if it is plus here, you have plus. If it is minus here, you have minus here. So, integral of sum is sum of integrals. Integral of difference of two is difference of integrals. My friends, this is the basic we needed. Then, by making use of what, my friends? By making use of what? Differentiation. We have a big list. Derivatives of what? Algebraic functions, trigonometric functions, logarithmic functions, exponential functions. We have inverse trigonometric functions. By making use of that list, derivative list, and making use of this definition of what? Integration. We can prepare or we can construct a list of formulae in integration. Then, as usual, everything about the integration starts, my friends. Starts. Yes, I hope it is clear. It is clear. Yes, friend. Yes. Yes. What is the next? Same starts, my friends. Starts. What is the first word? Using the list of formulae. Using the list of formulae in differentiation. Using the list of formulae in differentiation. In the differentiation and using the definition of integral. Definition of integral. Integral, yes, my friend. Jointly, we need this, we need the definition. We prepare the list of formulae. We prepare the list of formulae in integration, which is as follows. Yes, my friends, this follows is very important. This is the rest, my friends. This is the rest. Rest. See, the first, again I will go with what? Type wise. First, my friends, integral of algebraic functions. First is integral of algebraic functions. Algebraic functions. Along with I take what? Even exponential functions. Exponential functions. I make it what? This is one group. What is the second group? Integral of trigonometric functions. What is the next? Inverse trigonometric functions. What is the first? Algebraic with exponential, even that includes logarithmic also. Second, my friend, integrals of second is what? Integrals or here integrals of trigonometric functions. Again, third is what? Integral of inverse trigonometric functions. Then comes with what? Product formula, this, that, everything comes, my friends. Definite integrals, properties, every circus comes. Now, our thing is to using the list of formulae in differentiation, we prepare this, very important. We prepare a list of formulae in integration. First, algebraic. Tell my friends, what are the algebraic functions we have considered in case of what? Differentiation. In case of differentiation, algebraic and exponential functions I take here in the first. Algebraic and exponential functions. Algebraic and exponential functions. Yes, friend. Yes. What are the algebraic functions? My friends, you know these things, man. Derivative of what? Any constant each here. Even derivative of what? X is x with respect to x. Derivative of x with respect to x is 1. Like that, even derivative of, I used many times, I used to say derivative of kx is k, therefore derivative of 5x is 5. Derivative of kx is k, therefore derivative of what? 5x is 5, 10x is 10, like that. Now what is next? Derivative of x to the power n, you know the formula. It is n into x to the power n minus 1. Like that, even derivative of what? 1 upon x to the power n. Even derivative of root x, all these with algebraic functions. Algebraic functions. What about the exponential? Derivative of e to the power x is e to the power x. What about derivative of a to the power x? It is a to the power x into log a. Always the base is e. Like that, my friends. Derivative of e to the power ax. What is it? It is a to the power ax. What is your observation? It is not x. It is other than x. If it is other than x, write the derivative of power. Derivative of power is a. Why? Kx is k, ax is a. Like this, my friends, algebraic it is. By making use of this, I will just give the list of formulae in case of integrals of algebraic and exponential functions. Yes, my friends, I write one by one. I write one by one. First one, I take this itself. First, this itself. Yes, since the derivative of x with respect to x is what? Therefore, reversing, my friends, this reversing it gives reverse it. Integral of 1 RHS with respect to x is bracketed. This is bracket. Bracket is what? X. As usual, friend C. Yes, because indefinite. C1. If d by dx of gx is of x, reverse it. Integral of RHS with respect to x. Integral sign fx with respect to x is this bracket gx plus c. I have explained about that. C, my friend. C. This is 1. This is 1. Second, I write this also, my friends. Derivative of kx. Kx with respect to x. What is derivative of kx is k. Reverse it. Reversing here, my friends. It is what? Reversing. It is reversing. Yes. What is it? Reverse it. Integral of RHS k with respect to x is bracket this kx. This is what is this? This constant multiplied by x plus c. My friends, by making use of this math, you can directly write how integral of 5 with respect to x. What is it? It is 5x. Integral of minus 1 by 2 with respect to x. What is this? Minus 1 by 2 into x. It becomes easy, my friends. So if you remember this, what is that? Integral of k constant is that constant multiplied by x. Constant multiplied by x because of what? Reverse. Integral of RHS is bracket. Integral of RHS is bracket. What is the bracket, my friends? Kx. This is second. By making use of this, we can write this list, man, big list. What is that list? Integral of any constant is the same constant multiplied by x. Multiplied by x, my friend. X. That plus c is there. Don't forget. Actually, PUC board rule is what? If any friend doesn't write this plus c, they cut 1 mark. If it is under 1 mark question, if you won't write this c, you get what? 0. So much important, my friends, addition of c. That c denotes what? This integral is indefinite. Yes, my friend. Next one. Yes. Next one. This is 1. This is 2. This is 3, my friends. Yes. d by dx of I consider this x to the power n plus 1 upon n plus 1. I consider equal to, my friend, this is 1 upon n plus 1 being a constant coefficient. Constant coefficient remains. Then, for your sake, I am writing this step n plus 1 with respect to x. Simplify. So, what is this? It is 1 upon n plus 1 write its derivative. What is the derivative, my friend? Power into, what is the power? N plus 1. X to the power 1 less, my friends. Power into, what is the derivative of power of x? 1 less, n minus 1. N plus 1, what is 1 less? N plus 1 minus 1, this, my friend. What cancels? X1 plus n plus 1 cancels. You are left with what? It is x to the power n. Yes, my friend. See. Therefore, we get what we get? D by dx of x to the power n plus 1. Denominator is n plus 1 equal to, what is RHS, my friend? X to the power n. Oh, understood. Derivative of gx, fx. Integral of fx is gx. Yes, my friend, this implies integral of RHS, x to the power n with respect to x is bracket. Tell my friend, what is the bracket? X to the power n plus 1 upon n plus 1. This is x to the power n plus 1 upon n plus 1. Usual friend who? C. This is the formula. Yes, my friend. This is the derivative formula. Derivative of x to the power n is what? 1 power into 1 less. You are writing first power, then x to the power 1 less. What about in case of integration? The reverse. No. First what? Minus 1, add 1. Multiplication, what is opposite? Division. So in this case, integral of x to the power n is x to the power n plus 1 upon n plus 1, your friend. Therefore, while doing the examples, see, it is integral of x square with respect to x. Add 1, divide by the same, plus c. Yes, my friend. Integral of x to the power 100 with respect to x. See, add 101 upon what? 101 plus c. Yes, like this, my friend. Even if you wanted integral of 5 x to the power 4 with respect to x. Tell 5 as it is into integral of, what is it? It is 5 into, add 1, 4 plus 1, divide by the same, yes, plus c. 5 cancels. What is the answer then? It is x to the power 5 plus c. X to the power 5 plus c. Therefore, this you remember, this is your formula. Your formula. X to the power n is x to the power n plus 1 upon n plus 1 plus c. By making use of the same, even you can go for what? Fourth one. These are some examples, my friends. I explained. Yes. This is third formula. Yes, my friends. Copy it. Yes. If you wanted any one with fractions, it is integral of root x with respect to x. Yes, my friend, you are converting 1 by 2 with respect to x. What your formula says, x to the power n plus 1. If you simplify this, 1 by 2 plus 1 is 3 by 2 divided by 3 by 2 plus c. You are simplifying this. What is it? X to the power 3 by 2. If you simplify, it will become what? Reciprocal. 3 by 2 becomes 2 by 3. Hence, my friends, if it is a fraction into, into. Reverse means what? Reciprocal. Plus C. Like this, my friend, if you wanted one more. This is the integral of, it is cube root of x to the power 4 with respect to x. Sometimes one more question, the friend examiner may ask us a simple examples. See, what is it? Convert it. This is integral x. P is 4. This cube root becomes down 4 by 3 with respect to x. Whatever formula says friend add 1. Yes, add. What is this? 4 plus 3, 7 upon 3. This denominator will be in the numerator. 4 plus 3 will be down. Plus C. So it is x to the power 7 by 3 into 3 by 7 plus C. Yes, my friends. These are some verifications based on this formula. What is that formula? Integral x to the power n dx is what? X to the power n plus 1 upon n plus 1 plus c. N plus 1 upon n plus 1 plus c. Yes. And the fourth formula. Yes, my friend. Take it. Fourth formula. Yes, my friend. The fourth formula is integral of 1 upon x to the power n. My friend, this formula is not true for what? For n not equal to minus 1 Ly. If you put n equal to minus 1 plus 1 will be what? Denominator becomes 0. When the denominator is 0, the expression in RHS becomes what? Undefined. To avoid that undefined, you must choose n other than minus 1. Yes. This is 1 upon x to the power n with respect to x. Same formula we want to apply. Lift to the numerator. Left. Same, add 1. It is x to the power, add 1, x to the power minus n plus 1 upon minus n plus 1 plus c. Simplify it. This n I take what? Out. This is 1 upon. Minus I take out. You get it as what? N minus 1 into. Push it down. 1 upon. Minus becomes plus. Plus becomes minus. Plus c. Combining, therefore, the integral of 1 upon x to the power n with respect to x. Plus upon minus c is I write minus 1. Denominator n minus 1 into x to the power n minus 1 plus c. This is your formula, my friends. This is your formula. What is it? Integral 1 upon x to the power n with respect to x is sign changes. This plus becomes minus 1 upon. What is this coefficient? 1 less. If it is n, it becomes n minus 1. What about the power of x? N minus 1. Then you would remember coefficient of x as well as power of x, they are same. It is equal to what? 1 less to the power of x in the given integrand. By making use of this, my friends, here remember where n is not equal to 1. Why, my friends? Phi n is not equal to 1. If you put n equal to 1, it becomes what? 0. When the denominator is 0, the expression in RHS becomes undefined. To avoid it, you must choose the value of n here other than 1. If it is 1, the formula is different. You should not apply formula for what? When n is 1, in that case it is 1 by x. You can't apply. You can apply only when this power is other than 1. Other than 1. Remember, my friends. Yes. See. See. Now the integral of 1 upon x to the power 2 with respect to x. Yes. Sign change. Yes. 1 power less. Yes. X to the same power. Coefficient and powers are same. Plus c. What is it, my friend? It is minus 1 by x plus c. Why? Minus 1 means what? It is x itself. Like that, my friends, you can write any number of examples here. Any number. See, integral. It is 5 upon x to the power 5 with respect to x. 5k, that k can be out, 5 is out. Integral 1 upon x to the power 5 with respect to x. See, this is 5. Sign change, minus 1. 1 power less, 4. X to the same power plus c. See, my friend, it is minus 5 by 4 into, or directly, minus 5 upon 4x to the power 4 plus c. Plus c. Like this, my friends, you can write what? Any number of examples. I write one more. That one more is integral of 1 upon root x. 1 upon root x. Root x with respect to x. See, my friend. First, that root, write it in the fraction form. Fraction form. Apply the formula. Yes, my friend. What is the formula? Minus 1. This is minus 1 upon n minus 1. What is n? Half. Minus 1 into same power. Half minus 1 is minus half plus 6. Yes, my friend, what is this? Minus 1 upon. Half minus 1 is minus half. It is what? X to the power minus half plus 6. Lift to the numerator. Minus. Minus of minus is plus. Reciprocal 2. Lifting to the numerator. X to the power half plus c, which is 2 times, x to the power half is root x plus c. See, my friend, it starts with what? Therefore, integral of 1 by root x with respect to x is 2 root x plus c. What is the method? Root, convert in terms of fraction. Apply this formula. Minus 1 upon sign changes, plus is minus. Yes, n minus 1 into x to the power n minus 1. Minus half. Minus upon minus is plus. Reciprocal 2 by 1. Lift to the numerator, this minus becomes plus. Plus half is nothing but what, my friends? It is your root x. Your root x. Yes, my friend. Yes, my friend. That is one, the special case. What is that special case? I said here, n should not be equal to 1. N should not be equal to 1. If it is 1, what happens? If it is 1, what happens? Yes, my friend, if n is 1, we get integral of 1 upon x to the power 1 means 1 by x. 1 by x. We can't apply this formula. 5 denominator becomes what? 25 and 1 minus 1. 0. 5 the power n. What is it? 1 less 1 minus 1 is 0. When the denominator is 0 undefined, we can't use this formula when n is 1. If n is 1, what you will do? Yes, my friends. We have to use this formula. What is that? The derivative of log x. Derivative of log x with respect to x is 1 by x. Reverse it. Derivative of x, log x is 1 by x. Reversing, therefore, reversing integral of 1 by x with respect to x is log x. Log x. But log of negative numbers are not defined. Log of negative number is undefined. Therefore, instead of log x, we write what? Log of absolute value mod x with e. With e. When the base is not written understood, it is e. Therefore, the integral of 1 by x is log mod x absolute value plus c plus c. Therefore, remember integral of 1 by x is log. Log means you have to make it what? Absolute value, because negative number is not defined because of this, my friend. Because of this. Therefore, all these algebraic, tell my friends what are the algebraic formulae? First formula, integral of 1 with respect to x. Integral of 1 with respect to x is x. As usual, this plus c is there. Next, integral of other than 1, k. That k multiplied by constant. Integral of x to the power n is what? X to the power n plus 1. Add 1. Divide by the same. Plus c. Plus c. Next is integral of 1 upon x to the power n with respect to x. What is it? Minus 1. 1 less n minus 1 into x to the power n minus 1 plus c. And finally, integral of what? 1 by x. 1 by x is, my friend, log of mod x plus c. Log of mod x plus c. And these are algebraic functions. Algebraic functions. My friends, remember. This is one part algebraic. Side by side, I explained the use of what? Those integral formulae. Yes, my friends, this is enough. Next, I go with what? Exponential functions and combined examples under 1 mark questions. Yes, my friends, thank you very much. Thank you.